Hello? Hi! Okay guys, sorry we didn't get to the new lesson today, so I wanted to finish it up for you in as a video so you can watch this and come back on Wednesday and we can actually do this lesson together, okay? So you guys, functions 6.6 compositions. It's very important and this is actually really fun, okay? How do you perform operations on functions, okay? So you guys, key concept is this. Functions, and you guys, the most important thing is the composite functions, okay? It's basically we're taking two different functions and combining them and creating a different function, okay? Alright, so here's some properties. These are from your book, okay guys? From your book. We have addition. F plus g, the function of f plus g of x is equal to f of x plus g of x. So I can write it either way, okay? Subtraction, same thing. If I have f minus g of x is equal to f of x minus g of x. Multiplication, I have f of g of x. F times g of x is equal to f of x times g of x. And I'll show you examples of this. Division, alright, is f of g, f divided by g of x is equal to f of x over g of x. Whereas g of x is not equal to 0, because we all know that it's a quotient, the denominator cannot be 0, right? Okay, and that's what this statement here reiterates. Read over that if you have to. Please stop the video and look at that. But you guys, I have a little comic for you here. Okay, so we get apples. That's function g, right? We're inputting function g. We can put apples. Well, in between f of g because lemons, but our output is actually oranges. So apple plus lemons equals oranges. That's what this is trying to show, okay? Input into g gives you lemons. And then you put lemons into your function of f and you get something else. That's what composite functions are, okay? You have two functions and you create a new function using it, okay? So you guys, part one, let's use the rules and let's do the function operations, okay? So you guys, let f of x equals 7x plus 5, g of x equals x squared. Let's perform each operation and find the domain of the result. Now, this is a new part, okay? Find the domain of the result, okay? So you guys, we're going to try these three. Why don't you guys try on your own, but I'll do the first one with you. So this means f of x plus g of x, right? Well, what's f of x? F of x is 7x plus 5. G of x is x squared. And when we simplify that, I get x squared plus 7x plus 5. And you guys, the domain of this is all real numbers, okay? All right. Try f of f. You guys, isn't this f of x minus g of x? Okay? We can rewrite that using the function property that we just talked about. So it's going to be 7x plus 5 minus x squared, in which case we get negative x squared plus 7x plus 5, and domain again is all real numbers, right? Because that means we can plug in any x value and we'll get real numbers. Nothing is out of the question, right? We can plug in any x values. There's no restrictions. G minus f of x, that means it's going to be g of x minus f of x. Are things going to change? Maybe slightly. Minus 7x plus 5, right? So the simplified form is x squared minus 7x minus 5. You guys, stop the video before I give away the answers, okay? And again, yes, you got it. Real numbers for domain, okay? Let's try something else here. Let's try more interesting situations, okay? F times g of x, okay? So that means it's going to be f of x times g of x, right? All right, so let's go f of x, which is 7x plus 5. And g of x is going to be x squared. All right, that's that. And we get 7x squared cubed plus 5x squared. And you guys, is there any restricted x values that we can't plug in here? No, so it's all real numbers again. F divided by g of x is going to be f of x, right? Divided by x squared, because this means it's f of x over g of x, right? And here, we're done, right? We can't simplify anymore. But you guys, it's all reals, right? But what can x be? Look, okay? What can x be? You're right. X cannot equal 0, okay? Except 0. You could say except 0, or you could say x not equal to 0. Same thing, g of f. G divided by f of x, so it's g of x over f of x, which is going to be g of x, which is x squared, and f of x, which is 7x plus 5. Again, it's all good. It's all reals, right? But x can't equal negative 5 over 7, right? because we can't have this equaling a 0. 7x plus 5 cannot equal 0, so we solve for 0. So we solve for 0, and we get x equals negative 5 over 7, okay? All right, so you guys, now I want you to stop, and you know what you guys should try? Let's go ahead and try these problems right now. Okay, so page 401, number 15 through 20 all. Let's try that right now. Do it right now in your Holmes books. Holmes books, okay? All right, come back when you're ready. Welcome back, you guys. Part 2, composition of functions. Now we get to the compositions, okay? Now we make apples into lemons and then to oranges, okay? So you guys, composition of functions. This is from the book also, Composition of Functions. Key concept is this. The composition function g with function f is written as g. We read this as g of f. And it's defined as g of f of x is equal to g of f of x. You guys, we could write it any way you like, okay? Domain of g of f consists of the x values in the domain of f. So the input is f, right? And your output and your f of x is in the domain of g. So you guys, f is your input and g of f of x is gonna be your output. So let me make that clear. So it's like this. G of f of x means you do this guy first. You do this guy first. So you do f of x first. And then you take that output and use it to find g of that value. And that'll give you your output. That's your second step. Okay, so you see how there is actually two different outputs. Input is your x value, output is your f of x, and then you take that output and use it as your input for g of x. Okay, so we'll do a few examples. Ready? All right, so you guys, let's try some. If that was confusing, don't worry. When we actually do the calculations, it's actually a lot simpler than you think, okay? All right, let's try a few, okay? So you guys, let's practice reading function compositions and do the following practice. I'm going to give you h of x squared plus 4, and g of x is equal to 2x. So what does this mean? H of g of 1. Let's actually read this, okay? H of g of 1. That's what it's saying. So you guys, you always do in first, okay? So g of 1 first. So you first do, you can read this as h of g of 1 if you want to, okay? That makes it easier because you do this first. So g is to g of 1, which is 2 times 1, which is 2. Now you take this new output and plug it in for your h of 2. And that makes 2 squared plus 2, which is 2 squared plus, 4 right here, right? So it's going to be 8. And that's your solution. Okay? All right? So you guys, try your h of g of negative 5. Okay? I won't do all of them. But this actually means h of g of negative 5. So you do this first, and then you do this second, using the output from g of negative 5. So g of negative 5 is going to equal 2 to the negative 5, which is negative 10. Okay? And now you do h of negative 10, which means everywhere that you see the x, it's going to equal negative 10 squared plus 4, which is 100 plus 4, so it's 104. This is your final solution, all right? Try number 29 on your own, and you should get 20. Okay, try it though, all right? And you guys, I'll give you the answer for the next two too. For 30, which means g of h of negative 2 first, and then you do second. I got the solution, 16, okay? This guy here, I'm going to do this one, okay? G of h of 0, okay? So I'm going to do h of 0, which is equal to, everywhere you have x, you put in 0. 0 squared plus 4, which is 4. Now you take g of 4, which is 2 times 4, which is 8. So this is my final answer. Now, this one is an A. Ooh, so hard. Not at all. You take h of a first, and then you plug it into g of h. Okay, so h of a is going to be, instead of putting an x squared, you're going to put a squared plus 4. So now, g of a squared plus 4 is what you're going to take. The output of your h of a is going to be your input for g of x, which is going to be 2a squared plus 4. So it becomes 2a squared plus 8 is your final answer. Check that, okay? Ask me tomorrow if you have any questions, if you don't understand something, all right? Alright, so next you guys try some more. Okay? Don't forget what our original functions are. So let's try this guy here. So you guys, I'm going to try these guys. G of A, so G of A first, right? Okay, let's plug in G of A. G of A is going to be 2A, right? That's done. Now G of 2A is going to be 2 times 2A, which is 4A. Okay, because it's 2A, but instead of putting an X, I'm going to put 2A. So it's 2 times 2A. 2 times 2A. Because G of X is equal to 2 of X, right? Okay, and you guys, I'm not going to do the rest of it, but you should get this one as A4 plus 8A squared plus 20. Okay, next one here is H of G of A, which is G of A, and then you take this, H of G of A. So this one I got is 4A squared plus 4. Okay, so you guys try to understand these and see if you can actually go through them. Okay, you know what else? Before I give you guys more, page 402, try number 36 to 42A. Okay, let's try this one, H of A. So H of X is equal to X squared plus 4, right? So instead of putting X, I'm going to put H of A. So A squared plus 4. Okay, now I'm going to take that output, put it into the H. H of A squared plus 4 is going to be A squared plus 4 squared plus 4. OMG. Oh yeah, it's right? Yeah, it's so crazy, this problem. Oh, this must be wrong, right, guys? Oh, it might be right. Let's check, okay? So you guys, I think it's right, okay? So you guys, isn't this really A squared plus 4, A squared plus 4? And just ignore the 4 until later. And when you actually simplify that, you do indeed get that. Because A squared plus 8A squared plus 16 plus 4, which is that, okay? All right, so you guys try that now, okay? Try those, okay? All right, well, let's actually try those, and I'll see you in class tomorrow, Wednesday. Bye.